Hello, I'm going to be teaching about simultaneous equations today, which involve quadratic and linear. So, just to recap, you've solved already for two linear simultaneous equations. Maybe A equals B plus C and B equals C squared. Let's not say squared, let's maybe say plus 3. So we have these two, system of linear equations. So one method that we have used is substitution. So we already know the value of B. We want to now our aim is to get rid of this B and express A in terms of C. So let's find B. Now we already know B, so let's just sub inside here. So A equals to C plus 3 plus C. Now if we simplify this, we get equals to 2C plus 3. This is substitution. Now let's try something with elimination. Let's introduce another system of linear equations. Maybe let's say 3 equals to 2a plus 3c. Let's say so 3 equals 2a plus 3b. Now let's introduce another linear equation. 7 equals to 4a plus 9b. Now what we're going to do is elimination. We don't need to isolate all these variables into do some funny magic. So what we're going to do is elimination. So let's solve this system of linear equations. So the first thing we need to do is eliminate the common variable. So you can see that this is a factor of 2 is a factor of 4, and 2 times 2 is 4. So let's multiply this entire thing by 2. So 2 times 3 equals to 2 of 2a plus 3b. We simplify this to 6 equals to 4a plus 9b. No, 6b, sorry. So 6 equals to 4a plus 6b. Now 7 minus, so we recall that let's get rid of this. So this is greater than this, so we'll just minus this from this. So 7 minus 6 equals to 4a plus 6b minus 9b, minus 4a plus 6b. Now we get 1 equals to 9b minus 6b, because these two are eliminated because of this, and you'll get 3b. Now let's erase this. Now 1 equals 3b, so 3b equals 1, reflexive equality. Then let's just shift b to 1 over 3. This is our solution. Now we have to use one of these linear equations to find a. So recall that 3 equals 2a plus 3b. So we can write 3 equals to 2a plus b is 1 over 3. So we can just write 1. Now 2a equals to negative, no, not 2a. If you move this 1 to the side, 3 minus 2, 2a equals to 2. No, equals to no, sorry, equals to 1. When we evaluate this, we will get 2. So, let's just simplify this. Cancel this, cancel this. A equals to 1. This is elimination. Now, we need to, before we can solve equations, simultaneous equations involving a quadratic and a linear, we need to learn about equating. So, let's use something like this system of equation that we used just now. So, let's write y equals to x plus 7. Okay? Now, we have another y equals to 2x plus 4. Okay? So, these two are the same, right? So y equals y. This is obviously true. Now, because y equals y, we can infer that these two are also equal. Because these two correspond to y. So, we can just write x plus 7 equals to 2x plus 4. Now, let's make this thing 0. So let's just shift this over here and also there. So 2x plus 4 minus x minus 7 equals to x minus 4 minus 7 is negative 3, and which equals to 0. Because y equals y and y minus y is obviously 0 because they're the same thing. Now, we know x minus 3 equals 0. Now, to find x, let's just shift this over here. So x equals to 3. Now let's just check our equations to make sure they match. So y equals to x plus 7, y equals to 2x plus 4 equals to 10, sub 3 in, and 4, so y equals to 2 times 3, 6. 6 plus 4 equals to 10. And these two are equal. Now, we already know that we can equate this. So, let's try to do this thing with a quadratic. Okay, now that I've taught you equating, let's apply that concept to solving this system of a quadratic and a linear. Now, firstly, to even equate, we need to isolate y. So how do we do this? We're just gonna bring these to the other side. So y equals to x minus 3. Now, we have these two. These are equal. Y is obviously equal to itself, so these two are naturally equal. So, to find the solutions, we're going to combine these and then we're gonna combine these, bring to the left hand side and set the right hand side to 0. So, y equals y, therefore x squared minus 4x plus 1 equals to x minus 3 because of this. Now, what we're going to do is, let's bring this to the other side. So, x squared minus 4x plus 1 minus x plus 3 equals to 0. Now, let's just simplify this equation a bit. So, we get x squared minus 5x plus 4 equals to 0. Now, you just need to, once we solve this equation, we'll get the results x equals to 4 or x equals to 1. Now, let's just quickly find the y with one of these identities. So we've already been given these two equations. So the easiest way to find y is using this. I don't want to like substitute 4 and square and stuff. So we'll just use this. Because y equals y, so this equals this. Now let's just compute this quickly. So 4x equals to 4. We have the case y equals to 4 minus 3 equals to 1. Now 4x equals to 1. Y equals to 1 minus 3 equals to -2. Yeah. So the solutions to this equation are 4, 1, and 1, -2. I'm giving this in the form x, y. Now, we've already equated this. So, I'm going to give you I'm going to give you like a small exercise just as I end this video. So, you already know that you have to isolate y, and you have to isolate y, equate the values, and then solve by bringing all to one side and equating the other and setting the other to 0. So, the exercise is and 3x squared plus 2y squared equals to 11. So try to make a method to solve these. The solutions are 1, -1, and 2, and we also have 1.4 and -1.6. So these are the solutions. Now what I'm going to ask you to do is find these solutions. Do the method of equating to find these solutions. And just one tiny note. Just this one tiny note. Remember this.